We're going to skip ahead to question number 3 for today's lesson. And I want to kind of talk about more systems of equations with word problems. And what you see here is if we read this problem, it's talking about a candy shop and it's talking about price per pound. That should be a dollar sign. And what happens is if we think about what we just learned about today in class, we talked about concentration with liquids, but we also talked about distance equals rate times time. Neither of those apply to this one, but it's still kind of set up in a very similar way. So take a minute and read, and then we're going to set up 4 columns. And it says, in a candy shop, chocolate which sells $4 a pound is mixed with nuts which are sold for $2.50 a pound, are mixed to form a chocolate nut candy that sells for $3.50 a pound. If you think about this, hopefully that should make sense. Nuts, if I just sold mixed nuts, they're historically a little bit more costly than just pure chocolate. But if I want to mix both of them together, then that's going to change the cost of the mix because you're not going to pay $4 to have chocolate thrown in if we can just buy it separately. So what happens is we think about what's important when we mix these together, just like with the concentration. And what's important is the price per pound, and it's also how many pounds we have, so the amount. So again, the amount matters, but now instead of the concentration, it's the price per pound. And again, this is really a mixture problem. Just instead of liquid with concentration, we're talking about with money and actually tangible or things we can grab. So think about what we're mixing together. So what are we adding into this bag? We're adding nuts and we're adding chocolate, and it's going to make us a mix. How much was the nuts? Well, the nuts were sold for, the nuts were $2.50. So maybe I had that a little backwards, depending, I guess, what kind of chocolate. And then we have $4 for the chocolate. When we mix these together, we want to have a price point of $3.50. And so we got to figure out how much we should have of each to make sure that the mixture is 30 pounds. So the mixture has to be 30 pounds. And so what goes here and here? Well, those are our unknowns. Those are our variables. So X is going to be the number of pounds of nuts. And we don't know the chocolate, so Y will be the number of pounds of chocolate. And this will be the total price coming from each section. So what we do is 250 times however amount of nuts we have. So 2.5 times X. This one would be 4Y. And then together, we're going to times that together to get our total price of both the nuts and the chocolate mixture, which is 105. And you can see, just like today, how the equation is kind of set up vertically in our table. So we have 2 equations happening. We're going to have X plus Y equals 30. And then we're going to have 2.5X plus 4Y equals 105. And what we're going to do is we're going to multiply the top one by, let's say, 2.5 or negative 2.5. And when I go to do that, that's negative 2.5x minus 2.5y. And that's going to give us negative 75. And then this one's going to remain the same. So we're going to do elimination because those line up pretty nicely. Those are going to cancel. I'm going to get 1.5y equals 30. And if I divide by 1.5, you're going to get 20. And we have to refer to what we have. So Y is pounds of chocolate. So we're going to get 20 pounds of chocolate. And if I backtrack it into my equation, x plus y equals 30, and I plug in 20, we're going to find out that there's going to be 10 pounds of mixed nuts. So in order to create 30 pounds, I would need 10 pounds of mixed nuts and 20 pounds of chocolate. What I would ask you to do is go back up and cross out number 2 and write down this problem instead. And then I would like you to pause the video and to see what you have in your chart. Okay, so go ahead, pause the video, fill out the chart to the best of your ability. So this is what you should have got for your chart. We're mixing TA, which I'm going to call, which is this $5.75 tea, with TB, which is the $1.05, and we should get a new tea that costs $1.50. So again, pause the video, make sure that your chart is correct, and then I want you to write the equations for these systems. Okay, those are the 2 equations that you should get. So again, check that they're right, pause the video, and then solve the system. Keep in mind that this problem did say to round to the nearest tenth. So you can see that I multiplied the top one by negative 1.05. That allowed me to solve for x, which gave me approximately 1.4 pounds of the $5.75 tea. And then when I go to substitute back in, then y is 13.6 pounds of the $1.05 tea.